Okay, so we have used the remainder theorem a couple of times here in order to figure out the y value for a particular x value. But before we get started on identifying factors, let's review a concept here about zeros. Now, we have solved for zeros several times throughout the semester, and we figured out that when we find zeros, we have found those points where the graph happens to cross the x-axis. So that's what makes zeros so important, right? We can identify those places where the graph crosses the x-axis. Okay, so let's take a look at a problem here. Suppose I look at k cubed let's see, let me try to make that look a little better here. I have k cubed minus k squared minus k minus 2 and let's say we divide by k minus 2. And suppose the question is this: is the given binomial a factor of the numerator? In other words, is k minus 2 a factor of k cubed minus k squared minus k minus 2? Well, if k minus 2 is a factor, then that means that positive 2 would have to be a 0, right? In other words, positive 2 on the graph would have to give you a 0 value for y. So let's let that sink in because this is very important. Again, the question would be worded something like this: is the given binomial, now binomial has two terms, so that's obviously the one in the denominator here, is the given binomial a factor of the given polynomial? Now the polynomial is going to be the numerator. And I don't know that this graph looks anything like it, but I'm going to use that just to illustrate a point here. If k minus 2 is a factor of the numerator, then that means 2, positive 2, has to be a 0. So in order to evaluate whether or not 0 is the y value when x is 2, I'm going to use synthetic division and the remainder theorem. So let's put the 2 here, and notice that my coefficients are 1, negative 1, negative 1, negative 2. And again, we need to make sure we have no gaps here, because if we do, we have to put a 0 there as a placeholder, and luckily we have a power of 3, a power of 2, a power of 1, and then a constant. So we're in good shape there. And I'm just going to drop the 1 down, and 2 times 1 is 2. If I add this column, I get a 1. If I multiply, I get a 2. I get a 1 again. And finally, 2 times 1 is 2. And notice that my remainder is 0. In other words, when x is 2, y is 0. Well, that means that 2 is a 0. Well, if 2 is a 0, that means x minus 2 would be a factor. So yes, x minus 2 is a factor for k cubed minus k squared minus k minus 2. Let's take a look at another problem. Suppose I have p to the power of 4 minus 8p cubed plus 10p squared plus 2p plus 4. Now, I don't know exactly what this would look like. I know it's a 4th power, so it's going to look probably something like this. I could graph it in Desmos, and that's not really the point today. But I want to know, is p minus 2 a factor? is p minus 2 a factor? Is p minus 2 a factor? Well, p minus 2 is a factor if 2 comma 0 is on the graph, right? Because if 2 comma 0 happens to be on the graph somewhere, let's say maybe here, if 2 comma 0 is on the graph, then we know that x minus 2 has to be a factor. So let's take a look. Let's plug 2 in. We'll put 2 in the box here. And then I'm going to put 1, negative 8, 10, 2, and 4. And now we just do the synthetic division, right? So that's going to give me a 1 here, a 2 here, a negative 6 here. Now, if you think I'm going a little fast, it's because we've already learned how to do this, right? We should know how to do this by now. And as sure as I said that, I will be the first one to make a mistake. So let's see. 2 times negative 6 is negative 12. And if I add this column here, that would give me a negative 2, which will give me a negative 4 here, which will give me a negative 2 here, and finally a negative 4 here, which gives me a 0 as a remainder. Well, that means that if x is 2, y is 0. Well, that means that means 2 has to be a 0, which means x minus 2 has to be a factor. So the question is p minus 2 a factor? Remember, the variable in this problem is p, my bad, so I'm going to say p minus 2. And the answer is yes, because the y value is 0. So hopefully that helps to understand the purpose of the remainder theorem. Now, what if you get something different here besides 0? Suppose I got negative 10 or something like that. Well, that means that p minus 2 would not be a factor because it would be off of the x-axis, right? Okay, so let's take a look at one more example and then we will go from there.